Alright. Oh, let me drink water first. Okay. Now we will take a look at the operating system 3ECPs. The link in the description, or well, I can copy this into the chat. Okay. First thing first, let me check the preface. Okay, welcome to this book. We hope you will enjoy reading it as much as we enjoy writing it. The book is called Operating System 3ECPs, available at this one. Wait, let me check. Okay, on the same page. That is a previously and homemates. The one of the greatest set of lecture note created. Okay, wait a minute. Let's continue. And the title is of previous me an homage to one of the greatest sets of lecture notes ever created by one Richard Feynman on the topic of physics. This book will undoubtedly fall short the standard set by that famous physicist, but it will be good enough for you in your quest to understand what operating system and more generally system are about. 3ECPs refer to the three major thematic elements the book is organized around: virtualization, concurrency, and persistence. Oh, okay. Virtualization, concurrency, and persistence. Virtualization or energy security. Okay. Oh, FSC. Alright. In discussing this concept, we'll end up discussing most of the important things an operating system does. Hopefully you also have some fun along the way. Learning new things is fun, right? At least it usually should be. Its major concept is divided into a set of chapters. Much of me is present a particular problem and then show how to solve it. The chapters are short and try as best as possible to reference the source material where the ideas came from. Really came from. Okay. One of our goals in writing this book is to make the path of history as clear as possible, as we think that helps a student understand what is, what was, and what will be more clearly. In this case, seeing how the sausage was made is nearly as important as understanding what the sausage is good for. There are a couple of devices we use throughout the book, which are probably worth introducing here. The first is the crux of the problem, right? Anytime we try to solve a problem, we first try to state what the most important issue is. Specifically out in the text, and hopefully so via the techniques, algorithm, and ideas presented in the rest of the text. In many places, we'll explain how a system works by showing its behavior over time. These timelines are at the essence of understanding. If you know what happened, for example, when a process went foul, okay. Alright. When the process went foul, you are on your way to truly understanding how virtual memory operates. If you comprehend what takes place when a journaling file system writes a block to text, you have taken the first step toward mastery of storage system. There are also numerous asides and tips throughout the text, adding a little color to the mainland presentation. Aside tend to discuss something relevant, but perhaps not essential to the main text. Tips tend to be generalisms that can be applied to system you build. An index at the end of the book lists of all these tips and asides, as well as quotes the odd plural of crux. Oh, okay. I hope this is big enough that for the text to be read. Okay. We use one of the oldest didactic method, the dialogue. Okay. Throughout the book has a way of presenting some of the material in a different light. These are used to introduce the major thematic concept in a busy way, as we will see, as well as to review material every now and then. Alright. They are also a chance to write in a more humorous style. Whether you find them useful or humorous, well, that's another matter entirely. Okay. At the beginning of its major section, we'll first present an abstraction that an operating system provides, and then work in subsequent chapter on the mechanism, policies, and other support needed to provide the abstraction. So what the abstraction in the operating system provide, and then the book will try to explain the mechanism, policies, and other support for those abstraction. Okay. Abstraction are fundamental to all aspects of computer science, so it is perhaps no surprise that they are also essential in operating system. Okay. Throughout the chapter, we try to use real code, not pseudocode, where possible. So, for virtually all example, you should be able to set them up yourself and run them. Hello, welcome, Kiki GR. I'm trying to run operating system now. But yeah, I'm still reading the preface of the book called Operating System The Easy Pieces. But why? Well, because it is interesting, I think. Oh, that sounds great. After I learn this, maybe be able to type them up yourself and learn them. Running real code on real system is the best way to learn about operating system. So I encourage you to do so when you can. So are you working professional or a student? Well, I'm currently on career break, so I'm neither, I guess. But yeah, I'm not a student currently. So we encourage you to do so when you can. We are also making code available for your viewing pleasure. Okay. In this one, right? Let me copy this in the chat. Well, so some of your project. Well, you can take a look at my Git repo here, in case you want to take a look. Okay, in various parts of the text, we have Spring in a few homework to ensure that you are understanding what is going on. Many of these homework are little simulation of pieces of the operating system. Wait a minute. We have spring in a few homework to ensure that you are understanding what is going on. And various part of the text. Okay. Many of these little homework are little simulation of pieces of the operating system. You should download the homework and run them to quiz yourself. Okay. The homework simulator have the following feature. By giving them a different random sheet, you can generate a virtually infinite set of problems. The simulator can also be taught to solve the problem for you. To solve the problem for you. Oh, is it some kind of simulator? Interesting. Thus, you can test and retest yourself until you have achieved a good level of understanding. The most important addendum to this book is a set of projects in which you learn about how your system works by designing, implementing, and testing your own code. Addendum, Wait, what is addendum in here? Let me check. Okay. It's a set of projects in which you learn about how the system works by designing, implementing, and testing your own code. A project, as well as the code example mentioned above, are in the C programming language. Okay. C is a simple and powerful language that underlies most operating systems and thus would add into your tool chest of language. Two types of projects are available. Two types of project. Okay. The first type is system programming project. These projects are great for those who are new to C and Unix and want to learn how to do low-level C programming. Okay. The second type based on a real operating system kernel or XV6. I think I've heard about this before, but I kind of forgot. This project are great for students that already have some C knowledge and want to get their hand dirty inside the operating system. At Wisconsin, we've run the course in 3 different ways, either R system programming, XV6 programming, or mix of both. We are slowly making project description and a testing framework available. Making project description and a testing framework available. The only repository for more information, if not part of a class, Then we will give you a chance to do this project on your own. To better learn and not part of a class this will give you. Oh. Then have a TA. What is TA? Yeah, I'm not sure. But not everything in life can be free, but books can be, okay? I think this one, right? I think I had to put this in the description, but I will put this in the chat. Alright, good night. If you are an instructor or if you are an instructor or professor who wish to use this book, feel free to do so. As you may have noticed, they are free and available online from the following webpages. Also, purchase a print copy from Lulu and Amazon. This one, again, link in the description. Look for it on the webpage above. Okay, this is the citation. The course divides fairly well across a 15-week semester. 15-week, okay. In which you can cover most of the topic within at a reasonable level of depth. Cramming the course into a 10-week quarter probably requires dropping some detail from each of the pieces. There are also a few chapters on Virtual Machine Monitor, which we usually squeeze in sometime during the semester. In the right end of the last section on virtualization, or near the end as an aside. One slightly unusual aspect of the book is that concurrency, a topic at the front of many operating system books, is pushed off herein until the student has built an understanding of visualization of the CPU and of memory. In our experience in teaching this course for nearly 20 years, students have a hard time understanding how concurrency problems arise. Why they are trying to solve it if they don't yet understand what an address space is? What a process is, or why context switches can occur at arbitrary point in time. Once they to understand this concept, however, introducing the notion of threats and the problem that arise to it to them become rather easy, or at least easier. As much as is possible, use chalkboard or whiteboard to deliver a lecture. On these more conceptual days, We come to class with a few major ideas and examples in mind and use the board to present them. Handouts are useful to give the student hands-out, concrete problem to solve based on the material. On more practical days, we simply plug a laptop into a projector to enjoy real code. This style works particularly well for concurrency lecture as well as for any discussion section where you show students code that is relevant for their project. We don't generally use slides to present material, but we have now made a set available for those who prefer that style of presentation. You need a copy of any of this material, please drop us an email. We have already shared them with many others around the world, and others have contributed their material as well. Nice request if you use this just link to them instead of making a local copy. This helps us track usage, millions of chapters download each month, and also ensures students get the latest and greatest version. The student. I thought there's someone in the chat. The students, if you are a student reading this book, thank you. It is an honor for us to provide some material to help you in your pursuit of knowledge about operating system. We putting back fondly toward some textbook of undergraduate days. The classic book on computer architecture, and hope this book may become one of those positive memories for you. You may have noticed this book is free and available online. That is one major reason for this. Textbooks are generally too expensive. Right. That is one of the problems. This book, we hope, is the first of a new wave of free material to help those in pursuit of their education, regardless of which part of the world they come from or how much they are willing to spend for a book. Finding that it is one free book which is better than none. We also hope are possible to bring you to the original sources of much of the material in the book, the great paper and person who have set the field of operating system over the years. Ideas are not pulled out of the air. They come from smart and hardworking people. And thus we should strive to celebrate those ideas and people where possible. In doing so, we hopefully can better understand the revolution that have taken place, instead of writing texts as if those thoughts have always been present. Further, perhaps such reference will encourage you to dig deeper on your own. Reading the famous paper of our field is certainly one of the best ways to learn. free in here does not mean open source. You can download the chapter and learn about the operating system. We believe it is important for a book to have a single voice throughout. Okay. A dialogue with the person explaining something to you. Alright. The Turing Award is the highest award in computer science. It's like the Nobel Prize, except that you have never heard of it. Okay, acknowledgement. Is that how you pronounce it? Important thing for now, but you have to have. Send us some feedback and help debug this book. Alright. And you could be famous, everyone. By providing help, you can be famous. Alright. Oh, okay. This is the person who helped. Maybe we can help too. You will see. In their suggestion for improvement. In addition, a hearty thanks to. Okay. Alright. Yeah. Special thanks again. Alright. Final words. It's famously said. Am I pronouncing this correctly? I hope so. Education is not the feeling of a bell, but the lighting of a fire. You was right, but wrong at the same time. Okay. You do have to feel the pain a bit, and this not urgently here to help with that part of your education. When you go to interview at Google and they ask you a trick question about how to use semaphore, it might be good to actually know what a semaphore is, right? But yet another point is obviously on the map. The real point of education is to get you interested in something. To learn something more about the subject matter on your own and not just what you have to teach us. Not just what you have to teach us to get a good grade in some class. See? Get you interested in something. Okay, as one of our father to say, learn beyond the classroom, everyone. That is why I usually going off on my own rather than just following the book. Maybe I will do that in this series too. We will see. We created these notes to spark your interest in operating system, to read more about the topic on your own. Read more about the topic on your own. To talk to your professor about all the exciting research that is going on in the field, and even to get involved with that research. It is a great field, full of exciting and wonderful ideas that have shaped computing history in profound and important ways. Right? I mean, that is one of the reasons I'm interested in the operating system, like what is going on underneath. That what make me curious. And when we understand this firewall, like for all of you, we hope it does for many or even a few. Because once that fire is lit, well, that is when you truly become capable of doing something great. Once that fire is lit, is when you truly become capable of doing something great. Alright? And thus, the real point of educational process to go forward, to study many new and fascinating topics, to learn, to major, and most importantly, to find something that light a fire for you. Okay, right. To find something that we are curious about, If we actually said this as with many famous quotes, the story of this gem is murky, right? What is it called? It's kind of hard to verify the famous quote, right? If this sounds like we are meeting some past history as Sonnis, probably. If this sounds cheesy, well, that's because it is. That's because it is. But you'll just have to forgive us for that. Okay, reference. Okay, let me check this. Oh, this is the operating system. Or maybe more like the kernel that the book talking about. Maybe. I haven't taken a look yet. Okay, think easy pieces. Its most brilliant teacher. Oh, basic book. The SIG is a chapter of Feynman lecture on physics. It is a fantastic read. Okay. SIG easy pieces. That might be interesting. The architecture, a quantitative approach. Book that encourages each of us at our undergraduate to pursue graduate studies. Okay. We later both had the pleasure of working with Patterson, who greatly shaped the foundation of our research career. Okay. The C programming language, right? Brian Greeningham and Dennis Ritchie. Everyone should have. By the people who invented the language. I don't have this book yet. Maybe I should get one later on. The structure of scientific revolution. The structure of scientific revolution. Oh. A great and famous read about the fundamental of the scientific process. Work, anomaly, crisis, and revolution are mostly destined to work hours. Okay. Alright, that is the preface. Now let's take a look at table of content. Branding bro. Okay. Welcome. Pintu. Okay, this is the table of content. Dialogue on the book. Okay. Introduction to operating system. So we will learn about virtualizing the CPU, memory. Oh, virtualizing the CPU. Oh, interesting. And then right off the bat, concurrency. Okay. Persistence, design goal. Oh, is this the goal of the, what is it called? All of this concept. Why we use this, or maybe something else. We will find out later on. Some history, summary, okay, reference, homework, okay, and then this one, virtualization, the abstraction, the process API, process creation, okay. Process state, data structure, summary. Oh, process state. This could be interesting. And also process creation. Right. I mean, I remember that Ken Thompson said that a computer is a state machine or something like that. So yeah, we have different state for the process, I guess. Again, we will see later on. The structure, summary, reference, homework, simulation. Oh, okay. Interlude, process API. Fork, wait, and then exec, system call, wait, not this one, I think this one, right? This is the POSIX one. Maybe this one, library function. I don't think this is the one. Well, maybe it is different. I'm still not sure. Okay, why? Motivating the API. Process control and user, useful to summary, reference, homework, simulation, code, okay, mechanism, limited direct execution, basic technique, the direct execution, restricted operation, switching between process, worried about concurrency, okay, scheduling, workload assumption, scheduling metric, first in, first out, okay. Yeah, I'm still not sure what this means. Limited direct execution. Well, at least I have something to look forward to. Okay, so that's time to completion first. Okay. A new metric. Response time. Round robin. Incorporating input output. Normal Oracle. Okay. MLFQ basic rule. Okay, this is scheduling, right? Another scheduling again. Multi-level feedback queue. Okay. Predictive post, better accounting. Another scheduling, okay, proportional share, ticket represent your share, ticket mechanism implementation, an example, okay, how to assign ticket, okay, straight scheduling, the Linux completely fair scheduler. Oh, okay. Wait, I thought it was cut off or something. Summary, homework, okay, multiprocessor scheduling, advanced, the processor architecture, synchronization, final issue is affinity, single quote, multiple queue scheduling. Is that how to pronounce this? I'm still not sure. Linux multiprocessor scheduler, summary reference, homework. Okay, summary dialog on CPU virtualization. Wait a minute. Is all of this CPU virtualization? Oh, interesting. Yeah, I mean, the introduction state about virtualizing the CPU first. Okay. CPU virtualization. Maybe the author should change this to CPU virtualization, but then again, I'm not really sure. Or no. Maybe on this one. Dialog on virtualization. Yeah, we will see. I mean, this one is memory virtualization, right? And I assume there is dialog summary for memory virtualization too. Just a minor change, I guess. But yeah, let's continue to the Continue checking on this memory virtualization. The abstraction address space. Early system multi-programming and time sharing address space. Goal summary. Yeah, I'm kind of wondering how the virtual memory works, Like, what is page? I mean, if we take a look at this, right, there is the term page fault here. And what is page in here means, a lot of articles that I found said that page is the smallest part of the memory that we can access, something like that. But yeah, I still have no idea. Memory API, okay. The malloc call, recall. Yeah, we kind of use this when, what is it called? When I learn C before this series, I guess. Hello Cora, good morning. Yeah, I probably need to get a breakfast soon. But yeah, good morning Cora. Welcome. Currently we are learning about operating system. At least we try to learn about operating system. And I'm now looking at the table of content, what we will be learning or something like that. Okay, this is about the memory virtualization materi. The common error, okay, underlying OS, operating system support, watercourse, okay, summary, and so on. Mechanism, address translation. Okay, assumption, an example. Dynamic hardware base. Relocation. Oh, is this the relog? Like this one, maybe? Where is it? The reallocation. I'm still not sure. Hardware support, summary, operating system issue, okay. Segmentation. Alright. We got segmentation fault quite often. So at least we will, well, hopefully we will understand more about segmentation that goes into segmentation fault in here. Which segment are we referring to? Right. What about the stack? Okay, support for sharing, fine grain, coarse grain segmentation. Oh, there's fine grain and coarse grain segmentation. Interesting. Operating system support. Okay. Free space management. Assumption. low-level mechanism, basic strategies to approach with free space mechanism. Is it something like free in here maybe? Wait, let me check. Maybe this one, right? Is it the free in here? Like the heap memory maybe? I'm still not sure. Okay, but we will learn about this too. Free space management. Okay, paging, right? Simple example and overview. Where are page tables stored? What's actually in the page table? Okay. Also too slow. Okay. A memory trace summary. Okay. Faster translation. I think this one, TLP stands for take a look buffer, if I remember correctly. Accessing an array who handles the TLP maze. TLP content, what's in there? Context switches. Replacement policy. Okay. Real TLP entry summary. Okay. Wait, measurement. Hold on a minute. A lot of the homework is simulation or code. Okay, interesting. Oh, there's also measurement. Yeah, I'm still not sure what the simulation homework or the code homework or even the measurement homework mean. Okay, we will find that out later on. Okay, where is it? I think this one. So I think the page table to this. Simple solution, bigger page. Okay. Yeah. Is having bigger page making things easier to handle? I am not sure. Hybrid approach, paging and segment. Multi-level page table, okay. Inverted page table, swapping the page table to text summary to text. Is that how to pronounce it? Beyond physical memory mechanism, swap space, the present page, the page fault, right? This one. Okay. What if memory is full? Right. The out of memory situation. If I understand correctly, or I assume at least. I mean, I haven't checked this one out. Text fault control flow when replacement really occur. Okay, beyond physical memory policies, cache management, optimal placement policy, a simple policy, first in, first out, FIFO. Okay. another simple policy, random, using history, LRU. What is LRU again? Wait. Oh, okay. Hopefully we get an explanation for that in like Vivo, right? We got this introduction, first in, first out. Are you? Yeah. I'm not sure what LRU stands for. Workload example, implementing historical algorithm, approximating LRU, considering 30 page. Okay. Order VM policy. What VM in here stand for? Virtual memory or virtual machine? I assume this is virtual memory. I mean, we have been talking about virtual memory for a while, right? We will see. Tracing summary, complete virtual memory system, VEX or VMS virtual memory, the Linux virtual memory system. Okay, summary on memory virtualization. Alright, now we are on concurrency. Okay, let's take a break first. I will go to the toilet for a bit. Be right back. The toilet is still occupied, so well, we need to wait. I mean, concurrency, an introduction. Where is thread? Example, thread creation. Why it get worse? Set data, okay. The heart of the problem, uncontrolled scheduling. The wish for atomicity. Waiting for another. Thread API. Thread creation, completion, log, condition variable, compiling and running. Okay. The basic idea: pthread logs, building a log, evaluating log, controlling interrupts, file attempt just using loads and store. Okay. Building working spin log with test and set, evaluating spin log, compare and swap, load link and store, conditional, fetch and add, too much spinning. What now? Okay. a simple approach, just see it. Alright, using sleeping instead of spinning. Different operating system, different support. To face log summary reference. Log-based concurrent data structure, counter-linked list, co-stable, okay. Condition variable, definition and routines, producer consumer, bounded buffer problem, covering condition, okay. Variable. Log-based concurrent data structure. Okay. Semaphore. Definition. Let me check. Oh, okay. Binary semaphore logs for ordering the producer or consumer, bound buffer problem, reader log, training philosopher, thread throttling, how to implement semaphore. Common concurrency problem. What type of bug exists? None. Deadlock bug. Deadlock bug. Okay. Concurrency advanced. Okay, let me go to the bedroom first. Be right back. Alright, let's continue. Event-based concurrency advance. Select or pull. Okay. Blocking system call, asynchronous. Input output, another problem. State management, right? If you are introducing asynchronous workflow, or not really workflow, asynchronous process, I guess, you will have another problem. The state management. Oh, persistence. System architecture, canonical device, okay. More efficient data movement with the LA. Device interaction fitting into the operating system. The device driver. Oh, there's IDE. Vortex driver. If what I assume integrated development environment, or maybe another IDE term, right? I mean, similar to this one. Where is it? This one, VM. A lot of people understand VM as virtual machine, right? But in this case, it might be stand for virtual memory. But yeah, I'm not sure if the IDE, where is it? What this IDE stand for? We will find that out later on, I guess. Historical node, okay. Hard disk drive, interface basic geometry, a simple disk drive, input output time, doing the math. Interesting. Disk scheduling, summary, okay. Redundant array of inexpensive disks. Okay, RAID. Redundant array of inexpensive text interface and read internal. Fault model, how to evaluate a RAID. Okay. Wait a minute. 0, 1, 4, 5. Why is it not 2 or 3? I'm still have no idea. Okay, we will find that out later on. Read comparison summary. The interesting read issue summary. Okay. File and directories. Okay, the file system interface. Creating file, reading and writing file. Reading and writing but not sequentially. Okay. So is this mean this is consequential? Read and write? Maybe. Set file table entries for and writing immediately with fsync. Let me check. Oh, okay. Yeah, this is the system call. fsync. Alright. Renaming file, getting information about file, removing file, making directories, reading directories, deleting directories, hard link, symbolic link, permission bit and access control list. Okay, making and mounting a file system. File system implementation, the way to think of file organization. The way to think. Okay. The inode, yeah. I'm kind of curious about the inode too. So we will learn about that later on too. Okay. Directory organization, file space management, reading and writing, caching and buffering, summary, locality, and the fast file system. Poor performance. Okay, text awareness is the solution. The cylinder group. Policies. How to allocate file and directories. Measuring file locality. The large file exception. A few other things about FFS. What is FFS? Fast file system, is that it? Fast file. Cylinder group. Few other things about FFS. Okay. Wait a minute. Where is the LRU? Beyond physical memory. Yeah. I don't think. Yeah, I'm still not sure what LRU in here. means pass file system. Okay, this one right. Measuring file locality, the large file exception, crash consistency, FSCK, and journaling. A detailed example, the file system checker journaling, crash consistency. Okay. Log structure file system. Essentially and effectively how much to buffer. Finding in nodes. Solution through indirection. The inode map. Oh, we are using indirection for inode. Interesting. Completing the solution. The checkpoint region reading a file from disk, a recap, the both directories, a new problem, garbage collection, determining block wavelength, policy question which block to clean and when. Crash recovery and the log summary, okay. Flash-based SSD, storing a single bit from bit to banks or plain, basic flash operation, flash performance and reliability, from raw flash to flash-based SSD, solid-state drive, I assume. The SSD in here stands for FTL organization, upgrade approach, unlock structure FTL, garbage collection, mapping table size, we're leveling, SSD performance and cost, data integrity and protection, disk failure modes, handling latent sector errors. Okay, detecting corruption. The checksum. We can detecting corruption from checksum. But then again, I'm not sure what checksum is about, Using checksum, a new problem. Misdirected, right. Is this, what is it called? Is this something like we are trying to access unallocated memory or storage maybe? Yeah, I'm still not sure. We will find it out when we get there. One last problem, right. Scrapping. I'm not sure. Okay. Overhead of checksumming on persistence. Okay. A dialog on distribution. But the system communication. Wait. Distributed system. Okay. Communication basic, unreliable communication layer. Reliable communication layer. Communication Abstraction, RPC. Oh, Remote Procedure Call. Okay, RPC, Remote Procedure Call. Okay. So we will learn about the unreliable layer first, and then what is the reliable layer is. Okay. Sans Network File System, NFS. Basic Distributed File System onto NFS focus. Simple and fast server crash recovery. Itu fast crash recovery. Statelessness. How do we create statelessness? Interesting. The NFS V2 protocol from protocol to distribute file system, handling server failure with idempotent operation, improving performance client-side caching. The cache consistency problem, accessing NFS cache consistency, application on server side while buffering. Okay. The Andrew file system. Oh. Okay, after network file system, there's Andrew file system. Is Andrew in here someone's name? Maybe. NFS version 1, problem with version 1, improving the protocol. NFS version 2, case consistency. Okay. Crash recovery, scale and performance. Okay. General index. Oh, there's also tips and cruises. Okay. There's a lot. It's gonna take a while. So let's enjoy the process, everyone. Okay, the dialogue. Here we go. Welcome to this book. It is called Operating System in 3 Easy P's. Even though there is 4 P's, the security one. Okay. Anyway, let's continue. And I am here to teach you the things you need to know about operating system. Called a professor. Oh wait, that make me curious too. Is security only, what is it called? Only explain briefly. Oh, it does. If we take a look, right, the table of content only until 51. This one. Okay, so maybe the security in here like extra chapter or something like that. Extra piece. Wait. Okay. So it is more than this page, most likely. Okay, welcome to this book. It's called Operating System in 3 Easy Pieces. And I am here to teach you the things you need to know about operating system. I am called Professor. Who are you? I am called Student. Yes, just call me Student. Hey Professor, I'm called Student, as you may have guessed, and I'm here and ready to learn. Sounds good. Any question? Allowed. Any question? Allowed. Let's put it that way. Sure, why is it called 3 Easy Pieces? Okay, we start from there. That is an easy one. Well, you see, there are this great lecture on physics by Richard Feynman. Oh, the guy who wrote Surely You're Joking, Mr. Feynman. Right? I haven't read this book yet. Maybe I should read that book at one point. Great book. Is this going to be hilarious like that book was? Well, no. That book was great, and I'm glad you have read it. Hopefully, this book is more like his notes on physics. Some of the basics were summed up in a book called 6 Easy Pieces. He was talking about physics. We're going to do 3 easy pieces on the fine topic of operating system. This is appropriate, as operating system are about half as hard as physics. I'm not sure if it is half as hard. I'm not sure about the half part in here. It might be equal hard as physics. Equally hard as physics. Okay, the student, well, I like physics. Okay, so that is probably good. What are those pieces? There are 3 key ideas we are going to learn about: virtualization, concurrency, and persistence. In learning about these ideas, we will learn about how an operating system works, including how it decides what program to run next on a CPU, how it handles memory overload in a virtual memory system, how virtual machine monitor works. Wait. System work, including how it decides what program to run next on CPU. Okay. How it handles memory overload in virtual memory system. Okay. How virtual machine monitors work. I'm still not sure what virtual machine monitor in here means. How to manage information on disks, and even a little about how to build a distributed system that works when parts have failed. That sort of stuff. Manage information on disks, and even a little about how to build a distributed system that works when parts have failed. Yeah. Okay. I have no idea what you are talking about, really. This is our current state, or at least my state. I have no idea what you are talking about. Good, that means you are in the right class. Alright. We are in the right class, everyone. I have another question. What's the best way to learn this stuff? Okay. Excellent query. Well, each person needs to figure this out on their own, of course. But here is what I would do. Go to class to hear the professor introduce the material. Then at the end of every week, read these notes to have ideas sink into your head a bit better. Of course, sometime later, before the exam, okay. Before the exam, alright. Read the notes. If you're reading the notes during the exam, I think that was called cheating or something like that. So yeah, read the notes before the exam to frame up your knowledge. Of course, your professor will not assign some homework and projects, so you should do those. In particular, doing project where you write real code to solve real problem is the best way to put the ideas within this note into action, right? Doing project where you write real code. Okay. That is one of the way to learn by doing the projects, right? As Confucius said. Oh, I know, I heard and I forget. Classic. I see and I remember. I do and I understand, something like that. I do and I understand. Okay. I do and I forgot. There's also a case like that. But in this case, yeah, let's try to be optimistic, alright? I do and I understand, hopefully, or something like that. Surprise! How did you know what I was going to say? It seemed to follow. Also, I'm a big fan of Confucius. Is that how to pronounce the name? And an even bigger fan of Sun Tzu. Okay, who actually is a better source for this quote. Wait a minute. Stun. Well, I think we're going to get along just fine. Just fine indeed. Professors, just one more question if I may. What are these dialogue for? Isn't this just supposed to be a book? Why not present the material directly? Good question. Well, I think it is sometimes useful to pull yourself outside of a narrative and think a bit. This dialogue are those time. So you and I are going to work together to make sense. To make sense of all of these pretty complex ideas. Are you up for it? So we have to think. Ooh. Well, I'm up for that. I mean, what else do I have to do anyhow? It's not like I have much of life. It's not like I have much of a life outside of this book. Okay. Me neither, sadly. So let's get to work. Okay. Get a life, everyone. According to alright. Tell me and I forgot. Teach me and I may remember. Inform me and I will learn. See. I mean, I learn the best by doing stuff, not just watching someone teach me something. Again, this might differ for each person, but it is for me, so I need to do some stuff, learn by doing things, something like that. Confucian philosopher said, not having heard something is not as good as having heard it. Having heard it is not as good as having seen it. Having seen it is not as good as knowing it. Knowing it is not as good as putting it into practice. Like putting it into practice. Later on, the wisdom got attached to Confucius for some reason. See, it's kind of hard to verify the quote, which person said which quote, right? Thanks to Joteng for telling us. Okay. That is the dialogue. Now the introduction. Well, maybe I should take a look at this on another session. Okay, so I guess that's it for now. Thank you for watching and see you next time. Bye bye.